Xiaoyang. So, we're going into the next chapter before the end of the semester, and this is the last unit we're going to do, the last test, and then we have a final, and that's it. So, let's finish strong. We're going to simplifying radicals. I know you haven't seen a video in a long time. I know you're excited to get back, and you miss some. I know you do. Don't lie. Alright. Simplifying radicals, 7.1. So we kind of want to talk about the concept because a lot of times like we miss out on like what are you really talking about. So basically radicals and squares and cubes and exponents are actually the same thing. They're just inverses of each other. Take a look. 3 is the number. 2 right here is called the operation. So what are you doing to that number? You're squaring it, so the operation square. What does that operation mean to do? That means write it twice. Now, inverses of each other. And what are inverses? They're opposite operations. It lets you go forward and backwards. Like you're driving a car forward, you drive a car backwards. The operation here is square root. There's a 2 there, usually leave it out. The operation there is a square root. And what does that mean? That means we ask ourselves, like over here, square means make 2, square root means take out pairs. So 9 is made up of what pairs, meaning like what 2 numbers multiply to be 9? It is 3 times 3. So we take out the pair and we did the operation. Our answer is 3. So do you understand how they're inverse of each other? Instead of 3 make 2, you make 2 3s. This one take out 2, take out 2 3s. Now let's go into something new. Cubed. The number is 2. The operation is cubed. So what does the cube tell you to do to the number? That means it tells you to multiply 2 3 times, which is 8. So what does that inverse operation mean? Inverse operation means do the opposite. So instead of making 3, we're going to now take out 3. So the inverse of cubed is cube root. So the inverse of cube is cube root. So what does that mean, cube root? That means you find out 3 numbers that multiply to be 8. So what 3 numbers multiply to be 8? You could break it down, and it's 2 times 2 times 2. So since these 3 numbers multiply to be 8, you could take one of those out, and you did the operation. Your answer is 2. How do you guys feel? Does the idea there, the concept is there? One more time. What's the number? The number is 2. What's the operation? The operation is 4th power. So what does that mean? What does the 4th power mean to do to that 2? That means you want to multiply 2 times 2 times 2 times 2 4 times. 2 times 2, that's 16. Perfect. The inverse operation, and these are obviously inverse of each other. Inverse of 4th root is 4th power, and inverse of 4th power is 4th root. So what does a 4th root mean? That means you want to take the operations 4th root. That means you want to see what 4 numbers multiply to be 16. So take a look. That's 2 times 2 times 2 times 2 is 16. Therefore, take out 4 of them. The answer is 2. How do you feel about the idea, the concept behind that? So operation, inverse operation. We've done this side already. We want to work on this side over here. So let's do a couple problems, and we'll go slowly. Okay, let's talk about some strategies in solving this problem. So, easiest strategies first is this. If you have, let's say, the square root of 25. You go, what does square root mean? Take out pairs, and you could sit and you think, what 2 numbers multiply to be 25? That's going to be 5 and 5. You take it out, the answer is 5. Pretty simple if you could sit and think about it. So, let's do cube root. What's the cube root of, let's say, 125? So you sit there and you think, what 3 numbers now multiply to be 125? Why 3? Because that's cube root. So you think, and that's going to be 5 times 5 times 5. There's 3 of them. Take one out. Cube root of 125 is 5. Sound good? Now, what happens if it's a little bit harder and you say you want to find the cube root of, let's say, 24? What 3 numbers multiply to be 24? Well, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, so I can't really think of anything. So right now, what do we do when there's no three numbers that exactly multiply to be 24? We break it down. We break it down. We do factor tree or crazy cake, but we want to break this down because there's something left over here that didn't work. So let's break down 24. What number goes into 24? Prime numbers only, we tried 2. 2 goes into 24, leaving 12. 2 again, 2 goes into 12, leaving 6. 2 again, leaving 3. 3 leaving 1. You take a look, we're looking at 3 of a kind. There's 1, 2, 3 2s. With the 3 left over, that's why we couldn't find a perfect number that matches that. So we take out the 2, that means a 2 on the outside. The cube root of what's left over? 3. And therefore, when you have something like this, you just break it down. This is 2 times the cube root of 3. How do you feel about that? Good? Awesome. So far, so good, right? Nothing too complicated? This idea still is the same with variables also. Take a look. It's the same idea with variables. Let's say I want to find the cube root of x to the 8th power. So x to the 8th power, we break it down. How many x's are there in x to the 8th power? Take a look. There's 1, 2, 3, 4, 5, 6, 7, 8. We want to take out how many of a kind? Look at the operations. This is a cube root, so we want 3 of a kind. Do you see any 3 x's multiplied there? Here's go 1, 2, 3. That's one set. Here's another one, 1, 2, 3. That's another set. Anything left over? No. So we take out this x, and we take out this x with what's left over, the cube root of x times x. I'm going slowly, and a lot of these steps you could skip, but I just want to make sure that I'm not confusing anyone. X times x is x squared times the cube root, and make sure it's times because everything's multiplied here, x squared. So x squared times the cube root of x squared. How do you feel about variables? Well, this gets a little bit more complicated as the numbers get bigger. What if I told you x to the 20 power, or 30 power, 50 power, or 60 power? Take a look. Do you want to write it 60 times? 20 times, 30 times? That takes too much time and too much paper, and it kind of feels like pointless. If you look at some strategies, if you look at it, when you're grouping, what is grouping? Grouping is actually an operation of division. So isn't grouping division? So then take a look. If I take 8 divided by 3, what would I get? 8 divided by 3, I'll get 2, remainder 2. Right here, 2 comes out with the remainder of 2. Interesting? Kind of? You want me to try one like that? Okay, thank you. I heard somebody. Take a look. What if I had this? The 4th root of x to the, let's go, 13th power. I could do one thing. Write it 13 times and group them together. But grouping is just division. So I'm going to do them both for you so you can see. First, I'll do division first this time. 13 divided by 4. 13 divided by 4. Well, 4 goes into 13 3 times with 1 left over, because that's 12 with 1 left over. So x to the 3rd with the 1 left over. Oh, sorry, that's the 4th root. With 1 left over. Sound good? And that's how you do that. Take a look over here. I'm going to write it out the long way. 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm taking out how many of a kind? 4 of a kind because of my operations of 4th power. 4th root. Sorry. 1, 2, that's 2 sets. Here's 3 sets with 1 left over. So how many sets of x's are we taking out? We're taking out 3 with 1 x left over, and this is a 4th root. Take a look. They're the same thing, but this is kind of like the idea of using math to kind of simplify it a little bit more for you. All right, let's do problems that I was going to do problems that's going to be on your work today. Let's do something like this. How do you find the cube root of 24x to the 8th y to the 9th power? Okay, first of all, we break down one at a time. Let's break down 24. Cube root of 24. I'm not sure, so I'm going to crazy cake that. 2 goes into a 12. 2 goes 6. 2, 3, and 3, 1. How many of a kind I want? Good. 3 of a kind. So take a look. Any sets of 3s? Right there's a set of 3s. Any others? No. So basically, 2 on the outside with the 3 left inside. Let's look at the x to the 8th. Do you want to go short way or long way? Short way? Alright, awesome. 8 divided by 3 is x squared with 2 left over. Is that right? Damn it. Yeah, that's right. And then y to the 9th, how many sets of 3 are there? There's 9 divided by 3 is y to the 3rd. And therefore, there's your answer. That's it. 6, 7, 8, 9. Yeah, looks right to me. Questions? How do you feel? Can you do this on a test? Homework? Alright, good. Let's try one more. Oh man, this one looks hard. Alright, how do you do something like this? A fraction. So, same thing we've done before. You know when you root a fraction, it's the same thing as rooting the top and rooting the bottom. So take a look. This same thing as cube root of 16 divided by cube root of 8x cubed. Now it becomes simple. It's something like we've done before in the last couple examples. We just need to do the top first and then do the bottom. Let's do the top. What's the cube root of 16? I'm not sure. I can't think of anything, so I'm going to break it down. 16. What goes into 16? Prime numbers only. 2, 8, 2, 4, 2, 2, 2, 1. I want sets of 3s. I see a set of 3 right there. That means 2 on the outside with the 2 left on the inside. Cube root. Top. Done? Good. Now bottom. Do one at a time. Do the numbers first, then the variables. Let's do the numbers. 8. I'm not too sure, so I'll break down 8. 8 goes 2, 4, 2, 2, 2, 1. Any sets of 3? Yep. Right there. Anything left over? No. So there's no radical for the 2. Let's do the x's. There's 3 x's, and I want 3 of a kind. That's just an x. Are we done? No. Can you reduce? Yeah. 2 goes into everything, therefore your answer is cube root of 2 divided by x. That's it. Ta-da! Alright, some of you might ask, well, can I simplify ahead of time? Can I simplify the 8 and the 16 ahead of time and then simplify? Yes, you'll get the same answer. So, give it a try. Good. Anything else? Last thing, let's talk about negatives before we end today. How does negative work? Can you have the 4th root of a negative number? No, you can't, right? You can only have negative roots of odd numbers, because then you'll have imaginary, or you have, in this case you won't, but for square roots you have imaginary, and we want to deal with just reals in this chapter. So we're just going to deal only reals, no imaginary this chapter. So for this, it's no good. So what if you have, can you have a cube root of a negative number? Yes, you can have odd roots of negative numbers. What 3 numbers multiply to be negative 8? Take a look. Negative 2 times negative 2 times negative 2 is going to be negative 8. Therefore, the answer is negative 2. So, when you have odd roots, you can have negative. When you have even roots, you cannot have negative. Therefore, it's not. We're just going to say no solution for even roots. Sound good? Your book also asks you to put absolute value. Absolute value also, same thing as making all the numbers positive. Usually they tell you that with variables, because you don't know what numbers variables are. So sometimes you want to say, oh, if the variables are positive, then we don't have to deal with this negative problem. Alright, that's it. I'll see you tomorrow, and have a great day, guys.